Welcome, 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 and thank you again for joining us here at the Hacking COVID-19 series brought on by MedISAO, Society and BioHacking Village. Today we have an amazing guest, Dr. Kevin Fu from the Archimedes Center for Medical Device Security, and he's going to talk about some of the work that he and some of his colleagues have been doing on decontaminating N95 masks. Take it away.
Oh, great to be here, Daniel. Yeah, I'm one of the members of what's become a large team of about 60 scientists and other professionals to help with the shortage of PPE, in particular the shortage of N95 masks for the healthcare workers, helping them to understand the science behind decontaminating these masks for reuse during this crisis period.
Awesome. So how have you guys been doing that? What kind of work have you been doing to help spread, create more PPE, or at least use the PPE that is already there?
So one of the major thrusts of this group is to synthesize all the knowledge out there about decontamination of N95 masks, in particular looking at two qualities. The mask integrity itself, making sure that it still filters, has an appropriate filter performance. And then second, understanding the viral inactivation. Those are two very different aspects to the project, both through literature synthesis and also members of the team carrying out experiments themselves.
What kind of increase do you think we could see if with this information, right? Like how much more useful now are the masks?
So I can't comment on how useful are the masks, but what I could say is that we've released a number of documents, including short one-pagers and then also longer length technical reports on the science behind different methods of decontaminating the masks. And part of this is helping the hospitals out there to understand what are the advantages and disadvantages of each approach, so that each hospital can make their own decision based on their own unique circumstances and resource limitations.
So have you found any method that seems to be the best at decontaminating and inactivating?
Yeah, there is no best method. Instead, what we focus on are three methods where we have found the most supporting evidence so far. I would not be surprised if more methods are included in the future as researchers produce more positive evidence of the effectiveness of each approach. But at present, the N95 decon team talks about HPV, that's hydrogen peroxide vapor. They look into UV, ultraviolet C, and then they also look at a form of using heat, in particular a high relative humidity heat. And those are the three methods at present that are discussed at length on the website in the technical documents.
Yeah, I really like the fact sheets that you guys put together. It really breaks it down into bullet points that I think people can understand easily and take something away from it very quickly.
Yeah, we hope those fact sheets are going to be helpful to those on the front lines in their decision making, because there are so many difficult choices to make here, and having a very succinct way of understanding the advantages and disadvantages to each approach, we hope will be helpful guidance.
How did you make this segue from cybersecurity to decontaminating masks, right? Like this, there's no electronics or security threat here.
Yeah, that's a good question. Actually, my laboratory has a long history in decontamination and sterilization. For a couple of our past projects, we often use decontaminated pacemakers and defibrillators explanted from patients in the research we've been publishing for the last 12 or so years. And also, we've done some work on humanitarian efforts. We were brought in as experts in electronics and cardiology several years ago to help a local project at Michigan called the My Heart, Your Heart program, where their goal was to reuse discarded pacemakers in developing countries such that persons without sort of Western level healthcare can have a second chance at life. In some developing countries, a diagnosis such as bradycardia, a slow heart rhythm, can effectively be a death sentence, but a pacemaker is very useful in treating that particular kind of arrhythmia. So in our laboratory, we worked on not only decontamination, but also testing pacemakers to see if their performance was still safe and effective. So part of what this experience has done is expose the team to the regulatory processes at the Food and Drug Administration, and also understanding standards for the difference between sterilization and decontamination, which we're able to very quickly translate into this much larger group of interdisciplinary professionals, everything from material science to computer science in the practice of medicine. We're able to make headway as a great larger team.
Wow, that's amazing. And I never thought about reusing a pacemaker. So it seems like you have a lot of experience in this decontamination, reusing of medical devices that typically would be discarded, I'm assuming?
That's right. Typically, when a pacemaker is removed from a patient, it is discarded in one way or another. Very often, they end up actually just discarded as biohazardous waste, sometimes returned to the manufacturer. But there's a long history of what can be done with these devices in other countries where they simply have no other option. You can almost think of it as a shortage of medical devices, similar to how now in the United States we have a shortage of PPE.
Awesome. Is there anything else you'd like to ask or plug or?
Well, I'll just say, I mean, obviously this is a crisis period and it's an awful time, and a lot of people in the healthcare profession are making some great sacrifices, and we're just trying to do our part on what we know best to help give them the PPE they need.
Awesome. Well, thank you so much for joining us here today. I know you're very busy, so I'll let you get back to it. And we'll have links to the N95 Decon website and those fact sheets we were talking about in the description. And if you want to go, just go to n95decon.org and you can check out more of the awesome work that you guys are doing.
All right. Thanks, Daniel.
Thanks.